In this video, we're going to talk about how to calculate the derivative of an arcsecant function. So d by dx of arcsecant is equal to 1 over the absolute value of x times the square root of x squared minus 1. Now, in order to calculate the derivative, we can read it this way. So the derivative of arcsecant x is equal to 1 over the absolute value of x times the square root of x squared minus 1 dx, which is to say, another way of saying it is the derivative of arcsecant of whatever is in this arcsecant argument here is equal to 1 over the absolute value of that argument times the square root of the argument squared minus 1 times the derivative of that argument. So let's say we were to do an example here. So we were given a function f at x equals arcsecant x to the power of 5. So how do we get the derivative of that? Well, we would just follow that same format. So we go f prime at x. Okay. Another way we can write it is we can write it in Leibniz notation. So f df at x by dx is equal to this right here. So 1 over the absolute value of this box here. Now in this case it's x to the power of 5. So go x to the power of 5 times the square root of x to the power of 5 squared minus 1 times, okay, we can't forget this bit here, times the derivative of whatever is this argument here, so times the derivative of x to the power of 5, and from our power rule, that will be 5x to the power of 4. We can then go ahead and simplify this function, or simplify this expression. So we'll put 5x to the power of 4 in the numerator over x to the power of 5 times the square root of, now x to the power of 5 squared, we just multiply the exponents, so x to the power of 10 minus 1. And now notice how these x's would cancel out here. So this would cancel out, and then we would just be left with 1x here. So we would have, as the final answer, 5 over x times the square root of x to the power of 10 minus 1. And that would be the final answer. So let's do another example here. So let's say we're given another function, we'll call it h at x. So h at x is equal to the arcsecant of negative 2 to the ex. So how do we evaluate this derivative? So again, it's the same process. We have a slightly trickier argument here, but it's not too difficult. It's just more steps. So h prime at x, which we can also write as d h at x by dx, okay, whichever way you want to write it, it doesn't matter, is equal to, okay, and I'm just going to isolate this here, and okay, is equal to 1 over, okay, this right here. So the absolute value of whatever is in this argument here. So in this case, it's 2 times e to the x. So in this case, we would get rid of the negative sign here because we're dealing with the absolute value. So it'll just be 2 to the power of e, or sorry, 2 times e to the power of x times the square root of this argument here. Okay, so negative 2 times e to the x squared minus 1. And then we're going to multiply all this by the derivative, okay, the derivative of this box here. And in this case, it's negative 2 times e to the x. So we're going to multiply by that derivative. So the derivative of negative 2 times e to the x is just itself. Okay, so times negative 2 times e to the power of x. Okay, and they're going to multiply by the derivative of x, which is just 1. We can then go ahead and simplify that. And what we'll notice is that the 2e to the x will cancel with this one here. And so we're just left with negative 1 over the square root of, okay, now this is all going to be squared. So so here I'll write it this way. So e to the 2x, and then it's going to be 2 squared, or negative 2 squared. So it's going to be 4 times e to the 2x minus 1. And that's how we would get our final answer. So you see what's happening here is we're just multiplying the two exponents here. So imagine if there is a 1 here. So we'd multiply these two exponents, so e to the 2x, okay? And then we're also going to square the 2 as well, or square the negative 2, which is just going to be 4. And that's how we get this here. So that is how you calculate the derivative of an arcsecant function.